Magandang buhay po sa ating lahat, lalo na sa mga nanonood sa kanilang tahanan. Stay at home lang po tayo para iwas COVID-19. Sa aking pong professor sa ECEE 424, Motor Drives and Inverter, Engineer Conrado Camilon. Hi sir, kamusta po? Ako po si Carla Ann V. Vicina from BSECE 5A. Narito po ako ngayon upang i-present or i-discuss ang aking ginawang proyekto na Microwave Communication Design. Una, kailangan alam natin kung ano ang ibig sabihin ng microwave. Kailangan meron tayong brief background tungkol sa microwave. Microwave communication po hindi po yung microwave na pinag-iinitan ng ulam, hindi po yung microwave na ginagamit pang luto, kundi yung microwave communication, microwave satellite po. Pangalawa, kailangan meron tayong specific na lugar. Kailangan natin mag-survey ng mga lugar kung saan maganda ilagay ang ating transmitter at ang ating receiver. Pangatlo ay ang path profiling, kung saan kukunin natin ang elevation, earth bulge, line of sight, Fresnel zone, path clearance. At ang sunod po ay ang link budgeting, kung saan kukumputin natin ang mga gains and losses ng bawat isa. At sa link budget din po ay malalaman natin kung ano ang mga materials na gagamitin at kung ano o magkano ang halaga nito. So, umpisahan na po natin. Uumpisahan ko po sa pagbabasa muna ng definition ng microwave. Microwave link design. Introduction to microwaves. Microwaves are electromagnetic waves generally defined as lying within the frequency range of 100 MHz or 3 meter wavelength to 300 GHz 1 millimeter wavelength. Microwaves are used in radar, radio transmission, cooking, and other applications that have become essential in our modern society. A system used for transferring the data between persons and equipments is called communication system. The system usually consists of individual communication networks, relay station, transmission system, terminal equipment, interconnection cable, and interoperations performing as an integrated whole. This is the example of microwave communication system. As you can see, it has transmitter and receiver. Advantages of microwave communications. It is able to transmit large quantities of data and it is relatively low cost. At syempre, kung may advantages, meron ding disadvantages. At ang disadvantages nito ay it cannot pass through solid objects and it is subject to electromagnetic and other interference. So, diba, bago tayo makapag-design ng microwave communication link ay may mga materials tayong kailangan. At ang isa dito ay ang antenna. The antenna that is operated at microwave frequency is known as microwave antenna. There are different types of microwave antennas over a wide range of applications including home communication-based applications. Classifications of microwave antennas. Microstrip patch antennas. Microstrip patch antenna are also known as patch antennas. A microstrip patch antenna consists of a radiating patch that is bonded to a dielectric substrate on one side and has a ground plane on the other side. Next is the horn antenna. Horn antenna or microwave horn is an antenna consisting of a waveguide whose end walls are flared outside to form a megaphone-like structure.
as shown in the below figure. These horns are widely used as antennas at ultra-high frequency and microwave frequency that are well above 300 MHz. These are used to measure the gain of other antennas as calibrating antennas and directive antennas for devices like automatic door openers and microwave radiometers. Next is the parabolic antenna. A parabolic antenna is an antenna that uses a parabolic reflector, a curved surface with cross-sectional shape of a parabola to direct the radio waves. The shape of the antenna is in the form of a dish, therefore, it is a popularly known as dish antenna or parabolic dish. Next is the plasma antenna, wherein a plasma antenna is a type of radio antenna in which the plasma is used as a development element. Instead of the metal elements that are used in traditional antenna, it uses ionized gas as a conducting material because this gas ionizes when transmission or reception takes place. And last but not the least is the MIMO antenna. In radio, multiple inputs and multiple outputs or MIMO are used, and therefore, the multiple antennas are used at both the transmitter and receiver ends to improve communications performance. It is one of the smart antenna technology. In designing a microwave communication link, the first thing you need is the site or area where you can place your transmitter and receiver. Next is the path profiling, which includes the distances, elevation, earth bulge, path clearance, line of sight, and the Fresnel zone. Lastly, the link budget, which deals with the materials that you can use. Also, the computation of the gains and losses. The area that was given to me is from Mount Liguayen in Lobo, Batangas to As-is, Batangas. The total distance of two from each other is 25 kilometers. Mount Liguayen in Lobo, Batangas has a latitude of 13.6992 degree north and has a longitude of 121.1883 degree east. It has an elevation of 692 meters. At ito po yung lugar niya na matatagpuan sa Google Map. Next is As-is Lemery, Batangas, kung saan dito po natin ilalagay yung aking receiver. As-is Lemery, Batangas has a latitude of 13.9532 degree north and has a longitude of 120.8843 degree east. It has an elevation of 100 meters. At ito din po yung lugar niya na matatagpuan sa Google Map. So, next is the path profiling. Path profiling is a graphic representation of the physical features of a propagation path in the vertical plane containing both endpoints of the path, showing the surface of the earth and including trees, buildings, and other features that may obstruct the radio signal. Ito po, sa Google Earth, matatagpuan mo yung Mount Liguayen at yung As-is in Lemery, Batangas. Steps in making path profiling. First is you need to calculate the earth bulge. Next is calculate the Fresnel zone, calculate the path clearance, and determine the line of sight. Earth bulge. Term used in telecommunication, meaning the curvature of the Earth's surface which limits the range of communication methods that require a line of sight path like high frequency radio waves, microwaves, or lasers. So, line of sight, ano nga ba yung line of sight? It is an electromagnetic radiation, which means waves travel in a direct path from the source to the receiver. So, from transmitter daw, papunta kay receiver. At ito po yung example computation ng earth bulge na kung saan ay distance 1 in kilometers times distance 2 also in kilometers divided by 12.75 constant K. At ito po yung kanyang sample computation. Ipapakita ko po mamaya yung aking pagko-compute gamit yung Excel. Next is the Fresnel zone. Fresnel zone are series of concentric ellipsoids that surround the path from the transmitter to the receiver. At ito din po yung formula ng Fresnel zone. 17.3 square root of distance 1 times distance 2 divided by frequency in gigahertz times distance in kilometers. Ito din po yung sample computation ng Fresnel zone using Excel. Path clearance equation. May given po na formula sa path clearance equation na kung saan ay path clearance equals to H1 minus HO plus this times 1 divided by total distance times H2 minus H1. H1 is earth elevation plus tower height at site 1. At yung HO naman po ay total height na kung saan ay yung earth bulge plus elevation plus straight growth plus distance 1 divided by total distance at yung H2 naman ay earth elevation plus tower height at site 2. Also the sample computation of path clearance 692. Kasi 692 yung aking first elevation at 100 yung aking last elevation. Line of sight formula. Line of sight is equals to H plus HO prime, and clearance from line of sight formula or C first is equal to line of sight minus HN plus HO prime. Next is the tower height. It is typically tall structures designed to support antennas for telecommunications and broadcasting. Para makuha mo yung tower height kay site A or tower height A, minus mo sa elevation 692 at saka si line of sight na 727. Ang lalabas dyan ay 35 meters. So, ang tower height A natin ay merong 35 meters. Dito naman sa site B, ima-minus mo si si 130 na line of sight kay 100 meters na elevation at magkakaroon tayo ng 30 meters kay site B na tower height. At pagkatapos mo i-input lahat ng data at i-solve ang elevation with earth bulge, ang total obstruction, ang line of sight, upper Fresnel, and lower Fresnel, ito yung makukuha natin graph. Yan. Tower height A, 35 meters. Tower height B, 30 meters. So, ipapakita naman po natin kung paano na-solve itong mga to. So, ayun, ito po yung aking Excel datasheet. Ipapakita ko po sa inyo kung paano ko po nakuha yung aking mga earth bulge, elevation with earth bulge, additional obstacle, total obstruction, Fresnel zone, path clearance, line of sight, and so on. So, una, in-input ko muna yung aking distance 1 na from 0 to 25 kilometers kasi 25 kilometers yung aking total distance. Then, kay distance 2 naman, 25 kilometers to 0 kilometer. Elevation, in-input ko muna isa-isa yung mga nakuha kong elevation bawat kilometer. At pagkuha naman ng earth bulge, katulad ng sinabi ko kanina, meron tayong formula na distance 1 times distance 2 divided by 12.75 times k, which is 4/3. Elevation with earth bulge, formula naman niya ay si elevation plus mo lang kay earth bulge. C3 plus T3 because elevation is in column C and in row 3. Also in T3 because earth bulge is in column D and in row 3. Additional obstacles naman, 20 meters kapag siya rainforest or puro puno, 4 meters naman kapag puro bahay. Total obstruction niya, pag plus mo lang si elevation with earth bulge at si additional obstacles. Fresnel zone naman meron din tayong formula. 17.3 times square root of distance 1 times distance 2, 3 because distance 1 is in column A and B, distance 2 is in column B. Divided by 11 may frequency and 25 may total distance. 0.6 times Fresnel zone, path clearance, elevation 1 plus tower height A minus total obstruction plus distance 1 divide total distance times my last elevation which is 100 plus 30 my tower height B. Line of sight, pag plus add mo lang si path clearance at si total obstruction. C first minus mo si line of sight, si Fresnel zone at si total obstruction. Tapos yung difference niya ay yun yung kay C first. First Fresnel zone naman, divide mo si path clearance kay Fresnel zone. Pagkuha naman ng upper Fresnel, line of sight plus Fresnel zone. Kay lower naman, minus second Fresnel zone times square root of 2. 2 because it is second Fresnel. Upper, again ulit. Pag upper, addition. Pag lower, subtraction. Sa terrain naman, rainforest, 20 meters. Houses, 4 meters. So, ayan po yung mga nakuha ko na value in using the computation of Excel. So, ito po yung aking graph. Nakuha ko si elevation, Fresnel zone, line of sight, upper Fresnel, lower Fresnel, upper Fresnel, and lower Fresnel 2. Tapos, kinuha ko po yung kanyang graph. Ito po yung lumabas. Next is the link budgeting. Link budgeting is the accounting of all the power gains and losses that a communication signal experiences in a telecommunication system, from a transmitter through a medium, using free space, cable waveguide, fiber, and etc. to the receiver. Materials used. Ano nga ba yung mga materials na ginamit ko sa aking pagde-design ng microwave? First is the antenna. Ginamit kong antenna ay 1.8 meter or 6 feet standard performance parabolic reflector antenna, single polarized, 10.15 GHz to 11.7 GHz. Brand name po niya ay Radio Waves. Specifications naman po tayo. Antenna type, standard performance parabolic reflector antenna. Size, 6 feet or 1.8 meter. Polarization, single. Electrical specification, operating frequency band, 10.15 to 11.7 GHz. Half power beam width, horizontal and vertical, 1.2 degrees. Cross polarization discrimination, 30 dB. Front to back ratio, 50 dB decibels. Gain low frequency, 43.6 dBi. Gain medium frequency, 44 dBi. Gain high frequency, 44 dBi. VSWR 1.37:1. Return loss is negative 16.1 dB. Mechanical specifications. Mounting pipe diameter and minimum maximum 4.5 inch or 11.4 centimeter. Net weight of 95 pounds or 42.8 kilograms. Next is the transmitter and receiver. Transceiver RF451 spread spectrum radio. Specification, frequency 902 to 928 MHz. Transmit output power range 10 milliwatts to 1 watts, 20 to 25 miles. Sensitivity of negative 108 dBm at 115.2 kilobytes per second. Waveguide cable. Flexwell brand. Elliptical waveguide E105 series 10 to 11.7 GHz. Sample computation of link budgeting. Transmitter waveguide loss with the formula of attenuation divided by the length times total length. Total length po ay yung antenna, half of antenna height and the tower height. 12.26 is the equivalent of my frequency, which is 11 over 100 meter or divide 100 meter times 35 meter plus 0.91 meter is equals to 4.40 dB. Transmitter output power 30 dBm. Transmitter antenna gain 44 dBi. Next is the effective isotropic radiated power or EIRP. EIRP has a formula of output power plus transmitter gain minus transmitter waveguide loss. 30 dBm plus 44 dBi minus 4.40 dB is equal to 69.6 dB. Next is the free space loss. Free space loss has a formula of 92.4 plus 20 log frequency in gigahertz plus 20 log total distance in kilometers. Substitute all the given. 92.4 plus 20 log 11 gigahertz plus 20 log 25 is equals to 141.19 dV. Next is the isotropic receive level, or IRL, is equals to EIRP minus free space loss. 69.6 minus 141.19 is equals to negative 71.59. Since nakuha na naman po natin yung EIRP at saka yung FSL, substitute lang. Receiver waveguide loss, kapareho lang po ang formula niya ng kay transmitter waveguide loss na may attenuation divided by length times total length. Babaguhin lang po natin yung total length kasi ang tower height B po ay 30 meters. 12.26 divided 100 meter times 30 meter plus 0.91 meter is equals to 3.79 dB. Next is the received signal level, IRL plus receiver gain plus receiver waveguide loss is equals to, dahil nakuha natin si IRL, given din ang receiver gain at nakuha natin si receiver waveguide loss, substitute all the given, and the answer is negative 23.8 dBm. Next is the fade margin. RSL, or the received signal level minus threshold, which is the sensitivity of the transceiver. By substituting all the given, the answer is 84.2 dB. Next is the reliability. Sa reliability, malalaman natin kung okay ba, reliable ba ang ating dinesign na microwave communication link. May formula na 1 minus 10 raised to fade margin minus 30 log total distance minus 10 log 6 AB times frequency plus 70 divided by negative 10. 1 minus 10 raised to 84.2 minus 30 log 25 minus 10 log 6 times 1 times 0.125 times 11 plus 70 divided by negative 10. The answer is 0.99 or 99.99%. Ibig sabihin po, pag 99.99% reliable ang ating dinesign na microwave communication link. So, ayun lamang po. Doon po natatapos ang aking presentation. Sana po ay kahit papano naintindihan nyo ang aking pagdi-discuss, pagpe-present. At I'm hoping na kahit papano po ay nagkaroon kayo ng knowledge about designing, about on how to design a microwave communication.